Assalamualaikum warahmatullahi taala wabarakatuh. Welcome to MCTE 2311 Signal and System Analysis. In this video, I will show you the solution to sample problem that I shown at the end of the video where I discuss addition of basic signals. So here we have question number 3 where you have x of t, that is the resultant signal that you get by adding these three signals over here. Okay, where one of them is a step signal and the other two are ramp signals. Okay, so over here I show the unit step signal and the unit ramp signals. Okay, so the question asks you to sketch, okay, this x of t. So in order to do that, first you have to sketch these individual signals. Let's call them x1 of t, x2 of t, and x3 of t. Okay, so the first one, x1 of t is equals to u minus t plus 2. Okay, so this simply means you have the unit step signal here. Okay, the time is inverted because of this negative, and at the same time shifted to the left by positive 2. Okay, so if I am to plot the graph for this signal, this is how it's going to look. Okay, so if you're wondering how do I get these signals, okay, you can watch my video where I discuss transformation of signals. Okay, in that video I explain in detail how to perform multiple transformation like this. Right, so for the second signal we have x2 of t, which is equals to r t plus 1. So what you have here is actually a ramp signal, okay, that undergoes a time shift, okay, time shift to the left. By 1 second. So if I am to plot the graph, I will get something like this. Zero until minus 1, okay, and then the slope is positive 1. Okay. The third signal, x3 of t is equals to minus r t plus 1. Okay, so the minus at the front here simply means that the ramp signal here is inverted with respect to the x-axis. Okay, and you also have a time shift to the left by oh sorry, this is t minus 1. So you have a time shift to the right by 1 second. So if I am to plot this, have 0 until positive 1, and then here if you plot like that, this is a ramp signal, okay, of slope -1 and shifted to the right by 1 second. Now the resultant signal, which is x of t, okay, is obtained by simply adding the x1 of t, x2 of t, and x3 of t. Okay, so you can do that. So we have 0. Let's do this slowly. You have amplitude of 1, 2, and 3. Okay, so if you look at the first graph over here, okay, you have an amplitude of 1 until t equals to 2. Okay, so from t equals to minus infinity until t equals to 2, you have amplitude of 1, and then at t equals to 2, the amplitude drop to 0. The second graph here, you have an amplitude of 0, okay, from t equals to infinity until t equals to -1. While for the third graph here, from t equals to minus infinity until t equals to 1, you have 0 value. Okay, so the resultant signal will have an amplitude of 1 from minus infinity until -1. Okay, because at -1 here, okay, instead of 0, now you have slope of positive 1. Okay, so now here you will have a slope of positive 1. So at -1 here, you are at 1. So at 0 should be at 2. At t equals to positive 1, you should have an amplitude of 3. Okay, so you go until t equals to 1. Okay, why we stop at t equals to 1? Because here at t equals to 1, you have a slope, okay, of -1. So here slope positive 1, here slope -1. So when you add, you will get a 0, okay, 0 slope. So it means starting at t equals to 1 here, okay, you will have a slope of 0, okay, straight line until t equals to 2. Now why we stop at t equals to 2? Because here at t equals to 2, the step input or the step signal, okay, have changed in the value of its amplitude from 1 to 0. Okay, so means the amplitude is dropping by 1 unit. Okay, so it means in your resultant signal here, the amplitude is dropping by 1 unit from positive 3 to positive 2. So this one will continue until infinity. Okay, so this is the sketch for x of t, which is the resultant signal that you get by adding these 3 signals over here. So I see you again in the next video where I discuss about composition of signals. Thank you.